In this video, I will present a trick that you can use in solving problems involving ratio and proportion. Usually when you have examples in school, like say for example, 2 is to 5 is equal to x is to 25. What you usually do to solve that is you cross multiply, right? Well, that works, but there's a problem with that. It's actually a shortcut, so it doesn't really give you an understanding of how a ratio and proportion works. So because it's a shortcut, you will not be able to use it when the problems get harder in the exam. So I'm going to teach you something that you can use to solve these problems, but at the same time, visualize or understand how those ratios and proportions actually work. And use that when the problems become more difficult. We'll start with simple examples first, and then we will keep on increasing the difficulty until you cannot use the cross multiplication anymore, so that you can see that this is a more versatile strategy than what you have been using before. Okay, so let's start. Let's say you have 2 is to 5 is equal to x is to 25. What you have to understand first is that what it means is that the ratio 2 is to 5 is equivalent to another ratio, and that ratio is x, which is an unknown number, is to 25. So this question is actually asking you, what would be the value of x wherein this ratio will be equivalent of this ratio? So that's what it means. So how do we solve that? This is the trick. What you want to do is to represent this given ratio into boxes. So this ratio, which means 2 is to 5, we can actually represent them using boxes, wherein we have 2 boxes is to 5 boxes. So let's pause here for a little bit. What are these boxes? These boxes represent a certain value that we don't know yet. These boxes also have equal value, which means that whatever the value of this box is equal to this, 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 and this. And if we are able to know the value of those boxes, that will help us in solving x. Okay, so let's proceed. So this is 2 is to 5. But then that is also equivalent to the ratio x is to 25. So what you want to do next is to match them. Right? So this is the first term. So this will be x. And then this is the second term. So this will be 25. So now what did I just do here? What I did is translate this equation into something that we can visualize. Okay? So what does this mean is that the 2 is to 5 is equivalent to x, which we don't know yet, is to 25. Now, remember that I have told you before that in order for us to know the x, we have to know the values of each of the box. Okay? So what can help us in finding out the value of each box? Let's take a look at this one. 5 boxes is equal to 25. So that should give you the value of a single box. If 5 boxes is equal to 25, then that means that each box is equal to 5. Right? So then this must be also 5. Okay? So look, we were able to solve the value of x. If x is equal to 2 boxes, which is just basically 2 5s, then that means that x is equal to 10. So the answer here is x is equal to 10. So this is where the strategy really shines when you have to solve problems. So what we will do next is we will be presenting problems with increasing difficulty to show you that no matter how difficult the problem is, the strategy works. So let's start. The ratio of apples to oranges is 2 is to 5. If there are 40 apples, how many are the oranges? So what I want to do first is to represent the ratio of apples to oranges in terms of boxes. So what I will do is I will make this 2 boxes is to 5 boxes. Again, those boxes should have the same value, so try as much as possible to draw them in similar sizes. Okay? And there. So, if there are 40 apples, so that means this is 40. How many are the oranges? So this is what we don't know, the number of oranges. Okay? But we can get a clue because if 2 boxes is equal to 40, then that should tell us that 1 box is equal to 20, right? So that means this is also 20, this is 20, this is 20, 20, and then this is 20. So the oranges, so the answer is there are 100 oranges. Okay, let's have another problem. Now, this problem is too difficult for the cross multiplication, so you really have to use our strategy. So the ratio of apples to oranges is 2 is to 5, so just same as before. If there are 140 apples and oranges, how many of them are apples? So the ratio of apples to oranges is 2 is to 5. But here, we don't know how many apples are there. And we also don't know how many oranges are there. What we do know is that the total apples and oranges, so this and this, their total is equal to 140. So meaning these 7 boxes, their total is equal to 140. So if 7 boxes are equal to 140, so that should tell us that each box is equal to 20. So that means that there are 40 apples because 2 boxes of 20 should be equal to 40. So the answer is there are 40 apples. Okay, another problem. The ratio of apples to oranges is 2 is to 5. There are 12 more oranges than apples. How many apples are there? So let's draw the ratio again. The ratio is 2 apples for every 2 apples. there are 5 oranges. There are 12 more oranges than apples. How many apples are there? So what we would like to know is, how many is this? This is what we don't know yet. Okay? What clue can we use so that we will be able to find out the value of each box? Here, there are 12 more oranges than apples. So here's the clue. There are 12 more oranges than apples. So where does that 12 fit in how we see the problem? That's what we find out. Where does the 12 fit here? Well, if you look closely, in terms of boxes, there are 3 more boxes for orange than there are for apples. So that means that these 3 boxes is 12, right? Because that's the excess number of oranges compared to apples. The total of 3 boxes is 12, then that must tell us that each box is equal to 4. So that means this is equal to 4, 4, 4. So that means that this is equal to 8. So the answer is there are 8 apples. Okay, next problem. The ratio of apples to oranges is 2 is to 5. If half of the apples were replaced with oranges, what is the new ratio of apples to oranges? So let's try solving that by once again drawing the ratio using boxes. So what does the ratio say? For every 2 apples, there are 5 oranges. If half of this were replaced with oranges, meaning what we have to do is erase half of this and move it here. Okay, so what's half of 2 boxes? The answer is 1. So what we need to do, 3. So what we need to do is to move this from here to here. So what we're being asked is, if we do that, what's the new ratio? Okay. So what do you think is the new ratio? The answer is, for every 1 apple, there are 6 oranges. So the answer is this. The ratio, let's make it the new ratio of apples to oranges is 1 is to 6. Okay, we are now down to our last problem. The ratio of apples to oranges is once again 2 is to 5. So if we add 2 more apples, the apples will be half as many as oranges. How many apples are there originally? So let's draw the ratio again. So the situation here is this. If we add 2 more apples, the apples will be half as many as oranges. Okay? So how do we visualize that? Because that's important. That will help us learn what's the value of each of these boxes. Well, if we want to add numbers like this, 2, we can actually do it here. Okay? All we need to do is just draw another box ideally with a different color. So draw another box with a number 2, okay, which represents the value of that box, which means that it's not really equal here because for these unknown boxes, we don't know yet what their values are. For this one, we know that it's 2, okay? Then what we know aside from that is that if we add 2 apples, that will be half as many as oranges. So if we add 2 more apples to what we already have, then there will be half as many apples as oranges. So what do you think is the half of these 5 boxes? The answer is 2.5. So that means from here to here, that's 2.5 bucks, right? So which tells us that this is 2 because this is the same as this, right? So if this is the 0.5 bucks out of the 2.5, okay, so if this is 2, then that must mean that this is also 2, right? Because this is just another half of this box. So that means that 1 box is actually equal to 4, which should tell us that originally there are 8 apples. So the answer is there are 8 apples originally. So there.